Hi guys, now we are going to discuss a problem given in the Codechef's Starter 218 contest named as deleting array again. So the problem statement simply states that we are given two arrays A and C, both of length n, both of length size n, and our task is to remove all the elements from the array A, and for deletion operation it is stated that it will cost us A of I into C of I. That is, deletion of an element A of I will cost us A of I into C of I. And we are told that after each deletion, the elements of the array are re-indexed starting from 1. I'll discuss that what this means, and our final goal is to minimize the total cost to delete all the elements of the array A. Okay, now first let's try to understand what happens when we delete an element from the array. Let's see what happens to the indexes. Let's take an example, a small example. Let's say A is given as 2, 5 and 7, and let's say costs equal to 1, 6 and 2, and let's say we have decided to delete the index 1, that is this one. If we delete the index here, what happens after re-indexing is all the numbers after it will again reduce by 1. That means starting from first number, this will become the same, and this number, as it does not exist, it will not count it, and this 2 again becomes 1. So the new array will be A is equal to 2 comma 7, that is 0 comma 1, and the question also states that the cost array does not get affected, so it will remain the same. I hope you understood this. Okay, now let's try to understand the solution for this problem. Let's consider an array A where elements are A1, A2, so on, and AN, and also a cost array, that is C1, C2, so on until Cn. Now let's try to understand by considering single element starting from left to right. First let's look at the element A1. We know that the indexes of the elements only change if an element to its left is got deleted, and for the first element there is no possibility of deleting an element to its left, so it is sure that we can only pair A of 1 with C of 1. So answer of 1 is always equal to A of 1 into C of 1. We can conclude that. So a first element is clear, but from the second element the things are little interesting. Let's say obviously we can say that for A2 we can definitely pair up with C2, but the interesting thing is for A2 we have a choice of selecting either C1 or C2 to pair, because let's say if we deleted the element A1, that means A2's position will be changed to A1, so that we can pair A2 as well as we can pair A2 with C1 as well as A2 with C2. We have a choice. So as we are trying to minimize the total cost, what we'll do is we'll take the minimum of these two and multiply with A2. The same way, if we consider for A3, the answer for A3 will also be A3 into minimum of A1, minimum of C1, C2 and C3. From this we can generalize that answer of AI is always equal to AI into minimum of C1, C2 so on until Ci. This will give us the most absolute minimum value for each element, and all we need to do is sum up the total, that is starting from I equal to 1 and until n, and what we do is ai into minimum of C1 until Ci, and this will give us the minimum answer. Okay, let's discuss the pseudocode and how to solve this problem. Starting, we'll have a total cost, that is TC starting at 0, and we can use the variable mini to track the minimum element that we have seen starting from left to the current element, and we can initialize with int max, and we'll run a for loop starting from I equal to 0 up until n minus 1, and inside the loop first we have to track the minimum element that we have seen, that is mini is equal to minimum of mini comma the cost of current I, and simply what we do is we increment the current elements cost to the total cost, that is plus equal to a of I multiplied by the mini, and we print the total cost in the end. That's it. I hope you guys understood. Thank you for listening.